Hello, welcome to my final year project demo where I'll be going through all my code files and I'll show you how to run the code files and what they're basically doing. So I implemented the nearest neighbor algorithm, decision tree algorithm, random forest algorithm, and SVM on Irish scikit. For each of them, for nearest neighbor, I implemented it in iris dataset, heart failure dataset, and wine dataset. And I also did a scikit classifier version called random forest iris scikit, nearest neighbor iris scikit, and for decision tree as well, heart failure, iris for decision tree scikit iris. So let's begin. First, we'll be going through the nearest neighbor. I'll show you how each one run. So we open it up. We run this through Jupyter Notebook. So here I have my Jupyter Notebook where you can see it's the nearest neighbor algorithm running an iris dataset using the scikit classifier. So first we always in the Jupyter Notebooks we always start from the top to down. So and it gets saved as you go along. So let's start. So first we're importing all the libraries and then we will be loading the dataset. Once the dataset is loaded, I decided to visualize the graphs by showing for example for iris I decided to show the sepal length, sepal width for basically the features of the iris dataset. So here I'm visualizing it using this graph. So we press run again and we move on to the next box. So here we run again and you can see it will display the graph again. So here it has plotted all the graphs again. So here this is my algorithm bit where I'm saying I'm using the classifier. So I'm first calling in the classifier, importing it, then running the algorithm, predicting it, getting the test error rate. Here you can see that, and again let me do that, and then here I can see that the predictions match using the scikit, and we run that. And here I've also done cross validation on k number of folds, 5 folds for cross validation. So here I'm running that as well, getting the scores, and this will give me the average cross validation accuracy, which it gave me 96%. So the actual accuracy was so it's given me average cross validation accuracy of 96%. Here I'm also scaling the data, so this is also an essential part, and that's me also drawing another graphs. Here you can see that the accuracy and the heart failure dataset, they remain the same. So as the number of neighbors increases, the accuracy remains the same. So it is 100%. Then I was doing hyperparameters tuning and using grid search, and it's given me these results. Again, you keep on running using this run button and you get your results. Right, let's move on to the next file. So before I forgot to show, I've got all my data sets here. So the heart failure data sets, the iron data set, and the wine quality. So these algorithms are actually calling these data sets. So when we say load iris, they're calling the iris data set here. Right, let's move on to the nearest neighbor iris without the classifier. This is a scratch version. We can cross that out. Okay. Right, again we're importing all the libraries. Let's run this through. So we're loading the data set, importing the libraries, and we're analyzing the data. Here you can see I'm analyzing the data by describing it, which will display like all the data's information. Here you can see I've decided to do another like bar graphs, bar graph and line graphs here together to show different kind of distribution for each. So like this is distribution for sepal length, sepal width. So we carry on with this. I've done more graphs with this. So this is again just me describing the data, as you can see. And then I run this again, and this is my implementation of KNN from scratch. Here I've got a method and the nearest neighbor method where I'm actually implementing the algorithm, and this is me running with k equals to 1. You can see the error rate comes to 0, and the accuracy is 100% again. And again I've decided to do the same graph because the accuracy again with the same number of k's it stays the same. This is the error rate this time, and it stays the same at 0. Right, let's move on to the next algorithm, which is nearest neighbor heart failure. So for this algorithm again, I imported the libraries and I analyzed the data set. You can see here, this is me displaying the head of the data set. Let me carry on. For each, I've done a histogram for each of the features which had this data set had. So for age, for diabetes, everything. You run this algorithm, and then this is where you're again at the implementation of nearest neighbor from scratch. So here you can see I've done object oriented program, put it all together in a class. So this is my implementation, and then again I'm running this through, and here I am basically importing the heart failure data set and getting the accuracy. The accuracy comes to 0.533, and also I'll be plotting more graphs. So these graphs are basically showing the accuracy versus the k value, which means then as the number of k increases, what happens to the accuracy, and this is as the number of k increases, what happens to the error rate. So I showed this model again. You run that. This is also it's running a loop where it's showing with each k what the actual values, what the actual accuracy is. Right, let's move on to the next algorithm, which is nearest neighbor wine. And here I'm again importing all the libraries, analyzing the data set. I carry on with the analyzation, describing it, pretty much what I did for the others. We carry on with this. So this is a bar chart showing the quality score of the wine quality wine data set. You can see the alcohol density. I did that graph as well. We carry on, we find the accuracy, and then we also get the error rate, and I've plotted the graph, error rate, and it's still running. When it has a start, it means it's waiting for the graph to finish. We'll just wait for that. See, so we've now got the error rate. As the k increases was the error rate, and as the k increases was the accuracy. So accuracy and error rate. Here we've done the hyperparameter tuning, where for each k what's the accuracy. Okay, right, let's move on to the, so it's here you can see it's calculating it. Let's move on to the decision tree. So for decision tree, again, I did the same. First I implemented it using scikit, and then I did the others from scratch. So here I'm importing their libraries. I'm describing the dataset again, getting all the bar charts, and this is also one of the graphs I did. So this is the matrix it's showing, and this is my implementation. So this is using again classifier, you can see, and this is getting the accuracy of the model again because it's decision tree on iris dataset is getting 100%. You can see here, this is the graph I drew for the iris dataset. How does the tree actually look like? So you can see here, and then this is what happens with the depth. As the depth increases of the tree, what happens with the accuracy? As you can see, it stables at 100%, so the accuracy is at 1. Right, let's move on to decision tree iris, which is similar to the one I did with Scikit, but this is with my own implementation. Again, importing all the libraries and loading the dataset. This is describing again, pretty similar. This is my implementation. So I've done object-oriented programming approach again with class node, decision tree node, where here I have the information gain and the entropy, and we carry on, and you can see here again I'm getting the accuracy for the iris dataset, which is again at 1, 0 error rate, 0 mean absolute error, only 100% accuracy you're getting with the iris dataset. You can see here at depth 2 of the tree is 0.97, the rest is stable. Right, let's move on to the iris data. Let's move on to the decision tree heart failure. Here I'm again importing the libraries, running my dataset. This is me displaying like the testing features. I'm basically trying to see what the training features were and the testing features, testing labels. Next we move on to the describing the heart failure dataset. So again, I am using these data.describe, these methods to call it. Here we get the data types of each. We get if there's any null values. So this is the visualization again for each, and this is my implementation of decision tree from scratch. So like I did before, I use the same method, so information gauge, entropy, and I'm running my algorithm. And for this heart failure data set, we want to see what the accuracy was, and it gave 70%, error rate was 30%, and you can see the mean absolute error is also 30. And we see here we do the same graph what we did for iris, where accuracy was 1, the rest was 0. Now you can see the difference between iris and heart failure dataset. So for each depth of the tree, so you can see it's telling me the accuracy, and then we can get the average accuracy using cross validation. Alright, let's move on to the decision tree wine. Again, I'm doing the same thing. We run from the top again. This is again self-explanatory, where we describing the dataset, calling my decision tree method, loading the wine quality dataset, and here I'm getting the accuracy, and this is me predicting. So this is the predicted versus actual of graph. I'm doing all the graphs here. This is the accuracy versus max depth. So the number of max depth in this tree versus the accuracy, you can see at the highest it was nearly 0.61. Right, let's move on to random forest. So random forest iris scikit. So again, we load the relevant libraries. Here we're importing using the classifier. So this is the classifier method on iris dataset, and we get the accuracy for iris using random forest 100% as we've had before. Here, let me run all these files. So I'm doing cross validation and ROC with 5 folds. You can see the average cross validation accuracy is 95%. I'm also doing ROC curve. So the ROC curve is pretty stable, and this is the hyperparameter tuning. Right, let's move on to random forest iris. This is again similar, but this is with my own implementation. So again, we describe the data set. So here, what first I was doing was getting all my getting the same decision tree. So this my decision tree class, and this is my random forest algorithm, where I'm calling the decision tree, and I'm making multiple trees here using this random forest class. This is my own this is my implementation, and then for the iris dataset, using random forest, you're getting 100%. Let's move on. You can see the average accuracy with each tree index. So the average tree accuracy is 98%. Right, let's move on to random forest half failure. Here I'm going through each, again describing, and again I have the same method for the decision tree, and I'm applying the random forest algorithm on this half failure data set, and I'm getting the accuracy and I'm getting the error rate. So accuracy for the half failure data set using random forest is 73%, and the error rate is 26.67%. You can see that, and at the end you can see for each, as the tree index increases, what happens to the accuracy. And this is my cross validation, where it's currently just doing it, and it gets the average accuracy of 82.61%. Now let's move on to random forest wine. So here again I am importing the libraries and then describing the dataset, the wine dataset. You can see again the bar chart, and here again I am using the decision tree method and making multiple trees using this random forest class. Here I'm getting the accuracy of 59.69%, so not very good with the random forest on wine dataset. You can see, and you can see the accuracy of each tree as it increases. So the average is 54.22%. So the cross-validated accuracy is, one second. So it's currently doing, as you can see, so accuracy for fold 1, 63, and it will be doing for each one. Right, let's move on to support vector machines. So this I implemented only using iris scikit. So I imported my libraries, I loaded the dataset and described the dataset again. Here I am describing the dataset. This is where I'll be calling my support vector machine classifier. I'm getting the accuracy for the iris dataset 100%. As you can see, getting the cross validation done. So average cross validation accuracy is 96.6%, so it's pretty similar to the what I had for others. And this is the ROC curve. Again, I've just done more graphs. All right, thank you for listening to this demo.